Well, hello everyone. I wanted to work really the most introductory problem possible for the new chapter we're doing, which really should be called interval notation. That's the heart and soul of the section on inequalities. The reason that is because interval notation is essentially the language of calculus. And obviously you can't do the later sections in this chapter 4 unless you really have nailed down an interval notation. Now, there's one thing working against you on this, and that is a math education in your past. The way you've been taught to graph on a number line works against what we need to learn here. And so, in a sense, I'm asking you to do some unlearning. And unlearning is much more difficult than learning. So I'm taking the time and I'm going to hammer the point here with 3 problems. And then the third problem I'll work is the one you're looking at right now. But first I want to show you what you need to unlearn. The way we were taught to graph both in elementary and high school, and even probably in your last math class at a community college, is to use an open circle when you want to exclude a point, and use a closed circle when you want to include an endpoint. And that's a very visual thing, and it works well. But for where we're headed in this class and in your next class, instead of an open circle, you use a left or right parentheses, depending upon which way the solution set shoots out. And for the closed circle that includes the endpoint, we use the left or right bracket. So let me bring in a site that teaches this stuff online. And whose site this is doesn't matter, but they give an example here. X is less than 4. And here is their solution, their graph. And they use the open circle to exclude 4, and then they show the arrow going to the left, all the numbers to the left of 4, excluding 4. So the graph isn't wrong, but it's not the way we want to do it these days. What I want to show you here is the way we should educate ourselves to do it. So let's do this, and you'll see why this is a better, more superior way of doing this. Let's bring in the problem, and let's do it the new way. Again, it's going to be all the points to the left, and that the arrow will continue to go to the left. But instead of using the open circle, what I suggest we use here is this right here, the right parentheses. And that tells the modern reader in mathematics the same thing that the open circle did. Why this is a superior way of doing this is because when you go to interval notation, you can simply read the answer right off the graph. You don't have to do a translation. In other words, you avoid a step, and every step you avoid is better because it's one less chance to introduce an error. And so I'm going to read the interval notation straight off of the graph, and it looks like this. Now, we never fence in infinity, and that's why I still have to use the parenthesis symbol over there. I've had students suggest, there ought not to be anything here. This is the right way to do it. And that makes good sense, but we have to demark where something begins and something ends. And so we use the left parentheses. Now, I'm going to do one more, and I want to go again to that website. And let's take a look at a slightly more difficult one. This is conjunctions or complex inequalities. X is less than or equal to 4, and x is greater than negative 2. And so x is less than or equal to 4 will be the closed circle, the way they're going to do it here, and x is greater than negative 2 will be the open circle, and here is their solution. And again, that's not wrong, but for where we're headed, it's not quite correct enough. Let's do it again on our own. X is less than or equal to 4, so x can be 4, and that means we want to use this symbol, which includes the endpoint. And then we are going to say, and simultaneously, x must be greater than negative 2. So that's these points going this way. And they run into these points here, and that's where we stop. And we will say x is greater than negative 2, which means we don't want to include negative 2. And so this is our symbol, the left parentheses. Why this is superior again is once I've done it this way, I can immediately translate it into interval notation. Here is the interval notation, simply copied from my graph. Very nice, very clean. Okay, now you should really pause the video right now and do this yourself. Here we go. X is less than negative 2. That's going to be this symbol here. Let's pop that in there. And then simultaneously, conjunction, x must be greater than or equal to -7. So it can be equal to -7 and it can be greater than -7. So we'll use this symbol and we put that here. Now all points that satisfy both of those things, that conjunction, that's what the and says, it has to meet both those conditions. These points inside here. And so I will hash in that right there. And there is the solution. And again, going to interval notation is a straight translation. And so there you go. There's our answer. So nailing interval notation is really essential. And I think if our elementary schools and our high schools had taught the brackets in the parentheses instead of the open circles and the closed circles, I think that learning interval notation would be a snap. And you'd get there instantly. And instead, people do fall down on this stuff. But it is the heart and soul of Chapter 4 and the heart and soul of calculus. So spend some time on it and nail it good.